Good morning, one and all. Today we are going to solve an economic load dispatch problem. Here, little bit confusion. Problem is little bit confusion. Data is given. Take down this problem. A power plant has three generating units with the following input and output characteristics. Q1 is equal to 0.002 P1 squared plus 0.86 P1 plus 20 tons per hour. Q2 is equal to 0.004 P2 square plus 1.08 P2 plus 20 tons per hour. Q3 is equal to 0.0028 P3 square plus 0.64 P3 plus 36 tons per hour. Here, where P1, P2 and P3 are the generating powers in megawatt, the fuel cost is rupees 25 per ton. The maximum and minimum possible generation for each units are 120 and 39 megawatt respectively. Find the optimal scheduling for the total load of 200 megawatt. By seeing this problem, you will get confused. Why? Because here Q1 and Q2, Q3 is given. So here Q1 is nothing but they have given the thermal coefficients, that is thermal station, that is coal equation in tons per hour, that is in tons per hour. So you need to and also fuel cost also given. Fuel cost is rupees 25 per ton, that is given. So what you need to do is you need to simply just multiply with this thing. So automatically your fuel cost function will come. So what is given in the problem? Fuel cost is given as 25 rupees per ton, and minimum and maximum generation is given as 39 megawatt less than or equal to P1 less than or equal to 120 megawatt, and demand also given as 200 megawatt. Hence, in this problem, the input output characteristics were given in tons per hour. So you need to just convert this tons per hour into rupees per hour, because rupees is given. The fuel cost is given 25 per ton. So what you need to do is you need to simply multiply with 25 with that equation. So Q1 equation is there now. So you need to just multiply with 25. So you'll get that equation will turns into rupees per hour. That is tons per hour will turn into rupees per hour, because that is 25 rupees per ton. Fuel cost is 25 rupees per ton. So if you multiply this, automatically rupees per hour will come. So here we are calculating F1 as 0.002 P1 squared plus 0.8 P1 plus 20 into 25 rupees per hour. So you'll get 0.05 P1 squared plus 20 P1 plus 500 rupees per hour. Similarly, F2. So whatever the equation, that is Q2 equation given, no, the same equation you need to take and you need to multiply with 25. While multiplying, we'll get the equation as 0.1 P2 squared plus 27 P2 plus 500 rupees per hour. Similarly, F3 also Q3 is given. Q3 that the fuel cost is given. So Q3 into 25. So here just multiplying it with the 25, you'll get the F3 as 0.07 P3 squared plus 16 P3 plus 900 rupees per hour. So there is no you need to solve with this method like that. Nothing was given. They asked just optimal scheduling. So if this kind of problem is given, the best method is to solve this by using the lambda iteration method only, because directly with the formula, lambda iteration algorithm, directly with the formula you can find out lambda, and also with the lambda you can easily find out P1 that is PA, P1, P2, P3. Easily you can find. So we are solving by using the lambda iteration algorithm. So first, what is the formula for calculating lambda? Compute lambda. So lambda is equal to PD plus summation I is equal to 1 to n, BI divided by 2AI, the whole divided by summation I is equal to 1 to n, 1 divided by 2AI. So here you need to mark what is A1, B1, C1, because AI, PI squared plus BI, PI plus CA. So A1, B1, C1, you need to mark clearly. And here F2 also A2, B2, C2, you need to mark. And F3 also A3, B3, C3, you need to mark. So you can easily substitute no here. So B1 divided by 2A1 plus B2 divided by 2A2 plus B3 divided by 2A3. Just substitute all these values. We are getting the lambda as 29.3225. So whether you just tell in the comment whether you are getting the same answer or not. Similarly, you need to calculate PI. What is the formula for calculating PI? PI is equal to lambda minus BI divided by 2AI. So here lambda is given 29.3225. So here lambda is given minus BI like B1 divided by 2A1. So B1 is minus 20 divided by 2 into 0.05. Just to simplify, you will get the answer as 93.225 megawatt. That is P1. Whether you are getting the same answer or not, you just tell in the comment. Similarly, P2 is equal to this lambda minus B2 divided by 2A2. Just substitute the lambda, whatever we calculated, just substitute and finally we can find out P2 as 11.6125 megawatt. Here, what is the unit for lambda? Here it is rupees per megawatt hour. So here P1 and P2 we calculate. Okay, so next P3. P3 also same lambda minus B3 divided by 2A3. Just substitute all these things and you can easily calculate P3 as 95.1607 megawatt. So here the limit also given. That is, if the limit is not given, you can just simply you can wind up this problem. Just calculate the demand and wind up the problem. But the problem limit is given. That is 39 megawatt less than or equal to PI less than or equal to 120 megawatt given. So power generating units P1, P2, and P3 satisfies the power demand, but P1 and P3 satisfies the minimum and maximum operating limit. So you need to check whether P1, P2, and P3 are all are within this limits or not. Just see P1 is equal to 93.225 megawatt. So it is in the limit. This is in the minimum and maximum generating limit. Next, P2. But P2 is equal to 11.6125 megawatt. But P2 violates its minimum operating limit. So set P2 to its minimum limits. So whichever is violating, set the P2 to its minimum limits. That already previously we solved similar kind of problem, many problems. So you just go back. The theory also I will just give in the comment so you can easily watch. So whichever violates its operating limits, you need to set to its minimum limits. Here, minimum limits means, so P2 now we need to set P2 to its 39 megawatts. So now we just set, but we need to verify whether the whatever the set value, whatever we set P2 value is correct or not. So from the optimality condition, so already this optimality condition also we derived in our previous classes. Just to go and watch if you're not understanding this. So optimality condition dFi divided by dPi is greater than or equal to lambda for Pi is equal to Pi minimum. So this condition has to satisfy. Then only P2 to its minimum operating limit. So dF2 divided by dP2 by taking P2 as 39 megawatt. So what F2 already given in the problem, you need to just differentiate with respect to P2 because F2 is given in the problem itself. Yeah, F2 given in the problem, you need to differentiate with respect to P2. F2 we need to differentiate with respect to P2. We are getting the answer as 0.2 P2 plus 27. Here P2 we need to substitute that 39 megawatt. Just substitute it. We are getting the 34.8. 34.8 is greater than 29.3225 because lambda is 29.3225. Already we calculated lambda here 29.32. So that this value, whatever the calculated value, 34.8 is greater than 29.3225. So this condition satisfied. Now only we so P2 whatever we consider is correct. Okay, so now only we just made this statement as correct. That is P2 as 39 megawatt. That is correct. If it is not satisfying, whatever we consider is not correct. Again, we need to do the algorithm again. Okay, so if this condition satisfies, so P2 to its minimum operating limit. So now only we are setting we are just conforming P2 to its minimum operating limits, that is as 39 megawatts. So P2 is 39 megawatt, 39 megawatts. So what is the next step in the algorithm? If you just watch that algorithm and again solve this problem, it will be very easy for you to solve that algorithm. Also, I will give in the description. Once again, you watch that algorithm, then you come solve this problem. Now P2 to its P2 is 39 megawatt. Here, what is the PD new? Now we need to calculate PD new. PD new is equal to PD old minus sum of fixed generation not satisfying the operating optimality limits. So PD old given in the problem is 200 megawatt from the problem data. Next, sum of fixed generation not satisfying the operating optimality limits. So only one generating limits only violating, because that only we can consider. Suppose two generating units violating means, so you need to consider two and you need to sum up that two generation and you need to minus you need to make a difference from this PDU. So here only one and already we fixed generation, that is the fixed generation is 39 meg. Just you need to minus with this 200 minus 39 is 161 megawatt. So PD new is 161 megawatt. Now we need to calculate lambda nu. So lambda nu, what is the formula? Lambda nu, same formula. Lambda nu is equal to PD nu plus summation I is equal to 1 to n, BA divided by 2A, the whole divided by summation I is equal to 1 to n, 1 divided by 2AI. Already we fixed the power generating unit 2 as 39 megawatts. So we need to neglect the fuel cost coefficient of second generating unit. So here you no need to consider the second generating unit because already we fixed that as 39 megawatt, and from that only we calculated new power demand. So we no need to consider that second generating unit. So just you need to skip. So lambda nu is equal to PD nu plus B1 divided by 2A1 plus B3 divided by 2A3. So you need to neglect that generating unit 2 coefficient because already we calculated. Next, 1 divided by 2A1 plus 1 divided by 2A3. Substitute all these values for all these fuel cost coefficients from the problem data. Just substitute it, simplify it. We are getting the new lambda value as 27.7249 after decimal 4 digits. So whether you are getting the same answer or not, you just tell in the comment. 27.7249. That is lambda nu as 27.7249. Now we need to calculate PA nu. PA nu is equal to lambda nu minus PA divided by 2AI. So lambda nu we calculated as 27.7249 minus B1 because BI, this is the general formulation. Now we are calculating P1 nu now. So B1 divided by 2A1. Just substitute all this fuel cost coefficient and simplify it. We are getting the answer as P1 nu is equal to 77.249 megawatt. Similarly, P3 nu also similarly lambda nu minus P3 divided by 2A3. Just substitute all the values for this and we are getting the answer as P3 nu is equal to 83.7492 megawatt. Now we need to just somebody what they will do is they will just stop this problem up to this. Then they will move on to the next problem. So if you stop up to this, only out of 10 marks, only 7 marks will be given. So you need to conclude the problem correctly. So next you need to take out all the values. So whatever the values we found out, all the values you need to write it properly like this. P1 is equal to 77.249 megawatt already we calculated. Next P2 also we already fixed and confirmed also 39 megawatt that we need to write. Next P3 also we calculated 83.7492 megawatt. And the minimum and maximum operating limits, that is 39 megawatt less than or equal to P1, P2, P3 less than or equal to 120 megawatt. This is also given in the problem. If it is not given, just stop up to that the problem is very simple. But if it is given, you need to check whether the generating units are within this minimum and maximum operating limits or not. So, and you need to write the conclusion like this. The power generating units P1, P2 and P3 satisfies the power demand of 200 megawatt, because 200 megawatt given in the problem. Yes, it is satisfied. While adding, you are getting approximately 199.999 megawatt. So it is approximately equal to 200 megawatt. So here also all the power generating units P1, P2 and P3 satisfies the minimum and maximum generating limits. Like that, you need to write this conclusion. For this conclusion itself, some 2 marks will be given. Up to this, if you solve, only 8 marks only will be given out of 10 mark question. So you need to take out the answers clear, write out the answers, highlight the answers clearly, and limits also. Sometimes 3 units limits will be given for first generating unit, some limit, second generating unit, third generating unit. Limits are given. Limits they will give separately also. That also you need to clearly write, and you need to write the conclusion clearly. Then only they will give the full marks. So this is the answer for this problem we are taking. So somebody, what they will do is they will stop the problem up to here. What they will do is they will calculate P1, P2, P3, and they will just write the conclusion. P2 violates the limits. Like that, they will wind up this problem up to here. So if you solve up to here, I think only they will give out of 10 marks, they will give only 3 marks. Okay, 2 to 3 marks only given, because it is very simple. Up to here, solving is very, very simple. Somebody will be stopping up to here. So you'll get a very less marks. You may feel like we did fully like that. Whenever limits is not satisfied and limits are given for the problem, you need to satisfy the limit. Then only the problem gets fulfilled. Always remember that point in your mind while solving this kind of problem. So this is the answer for this particular problem. So what they will do is, as I said before, they will be giving confusing here. So they will be giving some other notations like Q1 is equal to some equation tons per hour. So by seeing this, what they will do is, okay, this problem, something is given instead of fuel cost, something is given. Then simply we'll skip this problem. Once you read the problem clearly, then you come to know what is given and what we need to find out like that. So don't get confused in your exams. Thank you.